Hello, today we're going to continue with our factoring of the R polynomials. We're going to focus on the trinomials and then the polynomials with four or more terms. So I've got three examples here we're going to go ahead and get started with. Hopefully these will seem familiar to you because they're going to be very similar methods as what we did in our quadratics chapter. Where we were factoring our quadratic equations. The only difference is you might have a couple examples where we've got some higher degrees. Let's go ahead and get started with the first example here. We have 6d squared plus 7d minus 3, and I want us to factor that. Now remember, you always want to first look for the greatest common factor, and if you don't have one, then you're going to move on to the rest of our normal factoring. If I look here, though, I don't have anything I can take out, so I have no greatest common factor other than 1. So I'm just going to go ahead and jump into the actual factoring. When we know we're going to factor, we want to end up with two parentheses like this, especially for trinomials. And in order to figure out what goes in those parentheses, I'm going to multiply the first and the last numbers together. So 6 times negative 3, that's negative 18. So remember, I want something that's going to multiply to get negative 18, but add to get a positive 7. So what are my factors of 18? Well, my factors of 18 are 1 and 18. They're 2 and 9, 3 and 6. So which of these factors is going to get me a 7 out of it? Well, that would be the 2 and the 9. So now what I can go ahead and do is I can rewrite this with the 2 and the 9 as my middle terms. So I'm going to have 6d squared. And then instead of a 7d, I'm going to break this up. I'm going to have a plus 9d and a minus 2d. And the reason I have a plus and a minus is because 9 minus 2 is 7. And 9 times negative 2 is going to get me that negative 18. And then I bring down my minus 3. So all I did was just rewrite it with my two numbers here, my negative 2 and my 9 in the middle. And then I'm just going to group some things together. So I'm going to group the first two things together and the last two things together. And I'm going to take out a greatest common factor. So what can I take out of the first? Well, I can take a 3 out and a d out. And that leaves me with 2d plus 3. And then out of the second pair of parentheses, I can take out a negative 1. And that leaves us with 2d plus 3 as well. And remember from the last chapter when we used this method, our parentheses matched. So what was in parentheses is one of the factors, so 2d plus 3. And then what went on the outside, so right here, goes in our other set of parentheses, so 3d minus 1. And this is just one of the methods for solving or for factoring quadratics or equations similar to this. But you could also just guess and check your numbers. Some of you are much quicker at the guessing and checking, and that's perfectly fine. This method just happens to take some of the guessing out of it by finding these terms right away and then grouping things together. So, like I said, this is just one method. If you don't like it and you like the guessing and checking, by all means, use that. It's whatever approach is easiest for you. All right. The next example here, we have z squared minus 8z minus 10. So notice this is a 1 in front, so I'm just going to have z's in my parentheses. We can't take anything out of all of it, so no greatest common factor. So I'm going to have a z and a z. And then I have to think about my factors of 10. So I know 1 and 10 get you 10. 2 and 5 multiply to get you 10. And remember, I want to multiply to get 10, but add to get a negative 8. Sorry, and a negative 10. Well, 1 and 10 and 2 and 5 can multiply to get me 10, but none of these are going to get me a negative 8. So because none of these numbers will work, then this is not factorable. And when we can't factor something, you just write the word prime. All right, so this one, you can't factor it, doesn't work, so we write the word prime. We can't go any further. And if you were to actually solve this, and maybe if I was asking you to solve it, then you would have to resort to maybe the quadratic formula or something similar depending on the type of degree. All right, so that one's a prime example. And then the last one, notice that it looks similar to these first two examples, except the degree is to the fourth. So our factors are going to just look a little bit different. Now, when you have something to the fourth power, the easiest thing to do is to split it into equal terms. So I'm going to have an x squared and an x squared, because x squared times x squared is x to the fourth. And then I have to think of my factors of 81 that are going to multiply to get 81, but add to get 18. So the easiest factors that I could use would be 9 and 9. So I'm going to go ahead and plug the 9s in here. 9 times 9 is 81, and 9 plus 9 is going to get me 18. So now I've factored it. What you should notice, though, is that both of these are identical, and because they're exactly the same, I can rewrite them as x squared plus 9 all to the second. We did something similar to this back in the last chapter when we were completing the square. So anytime the factors are equal, make sure you write them as something to the second power if you've got two of them. All right, so either way is the same, just two different ways of writing those final answers. And that's it for our trinomials. Obviously, the examples are all going to be very different because they're going to have different numbers. So if you have any questions about how to factor using this method, let me know. The final method is our grouping method, and this is going to be used if you have 4 or more terms, because when you have 4 or more terms, you can't factor it like we did with the trinomials. So to use the grouping method, what you're basically going to do is just like what it sounds. You're going to pair or group parts of the polynomial together, and then you're going to use the concept of greatest common factor. So in this first example here, we've got 21 minus 7t plus 3r minus rt. So what you're going to do is you're going to, in step 1, you're going to group the terms. So I'm going to group the first 2 terms together and the last 2 terms together. Okay. Once you've done that, you're going to look for the greatest common factor. So to do that, I'm going to look at my first set of parentheses. Well, what can I take out of a 21 and a 7t? Well, I can take out a 7. So when I do that, I'm left with 3 minus t. Okay. Then I'm going to do the same thing for the next example, or the next part. I'm going to have a plus sign. Well, what can I take out of a 3r and an rt? The only thing I can take out of both is an r. And what I'm left with is a 3 minus t. So this is my step 2. Okay, and what you should notice when you do this is that what is in parentheses should be identical. If it is, grouping is a great method. If you group and it didn't match, then you maybe have to reorganize your terms, or you're going to have to use something other than grouping to factor. But because our parentheses match, what we're going to do in step 3 is rewrite the factors. All right, so what I'm going to do is take what's in parentheses and I'm going to put that out in front. So 3 minus t. Now notice, even though there were 2 of them, I'm only going to write it once because it's just an identical term repeated. So I'm going to write it once here. And then what's on the outside is going to go together in another set of parentheses. So I have a 7 plus an r. So 7 plus r, and now I'm done. So this is my factored version of my original 4-term equation. All right, so what I did is I grouped the first 2 and the last 2. I took out the greatest common factors, and then I just rewrote everything in 2 separate sets of parentheses, and we're done. So let's go ahead and try the next example just to get you used to the process. So I have 12x cubed plus 2x squared minus 30x minus 5. So again, I'm going to group the first 2 things together, and I'm going to group the last 2 things together. And I always want to have a plus sign in the middle of them. So notice I grouped the negative in with the parentheses because I want to have the plus sign there. Okay, so now I've done step 1 by grouping each of the sets. Now step 2, I'm going to look for my greatest common factor. So if you look in the first pair, I can take out a 2 and I can take out an x squared. And that's going to leave me with a 6x plus 1. Okay, that takes everything out of the first set. And then in the middle here, I can take out a negative 5, and that's going to leave me with a 6x, and a plus 1 on the inside. So you want to make sure if you can take a negative out to do that, because you want to make sure, remember, that my middle parts here in parentheses are identical. So I have the matching parentheses. So step 3 says rewrite your factors. So I'm going to have 6x plus 1 in one factor, and then I'm going to have the outside parts go together. So the 2x squared minus 5. And if I can't go any further, that's my final factors. So I factored by grouping, and that's it. If you have any questions on the 3 steps or where I got a number from, let me know. But hopefully you were able to follow along with those 2 methods. And if you have any questions over any of the methods that we talked about in these 2 videos, I will gladly come up with some extra examples to go with you through with you in class. That's it for today. Thanks for listening.